Welcome to LDI 1.9, the p-value. Well, before we actually get into LDI 1.9, let's go talk about what the p-value is. So let's go back to bag A and bag B for a second. In the bag A, bag B example, what if you had your bag and you reached into it and you grabbed out a $50 voucher from it? So what would be the chance of seeing that, or more extreme, given that the bag you were holding was bag A? In other words, what was the chance of getting 50 or larger out of the distribution of the null? Okay? Well, that's the basic idea behind the p-value. And it should be sounding a little bit familiar. This is exactly the idea of how we calculated alpha based upon a decision rule. We took a look at a critical value that was set in our decision rule and used that to calculate the probability of making a type 1 error based, of course, upon that decision rule. Well, now we're going to do that same calculation. We're going to calculate the probability of seeing an observed value or more extreme. And when we do that, we've calculated the p-value. All right? So, according to Martha and Brenda, the p-value is the chance computed under the assumption that the null is true of getting the observed value plus the chance of getting the more extreme values. So let's back up for a second here and take a look at some of these words. So chance, now what are we talking about there? That's, of course, it's a probability. So this is the probability given the assumption that the null is true of getting the observed value plus the chances of getting all the more extreme values. Okay? So what that's telling us is that we take a look at our observed value and we look at all the values in the direction of extreme from that value, use all of those to calculate the probability of seeing that value or more extreme, and that is the p-value. So now the p-value measures how likely the observed result is, or something even more extreme, given that we're calculating that in the distribution of the null. Okay? All right. So let's go take a look at bag A for a minute, and let's see if we can actually make sense of this. So let's say that in this particular example that we're going to have a decision rule, and our decision rule is going to be as follows. It's going to say reject HO if the voucher is greater than or equal to $50. Okay? So that's the rule that we're going to work by. All right? Now, let's say we go in and we reach into the bag and we grab out a different value than the $50. Let's just make it simple. We'll do it that way, okay? But before we do that, let's go ahead and mark our 50 here with CV underneath it, because we know that that's our critical value. And what we know is that any values that 50 or greater will cause us to reject the null hypotheses, okay? So in red here, I'm going to go ahead and do the calculation of alpha, all right? So the calculation of alpha here, we see is all the values to the right, so alpha is equal to 2 out of 20. Okay, now if you wanted to simplify that into a reduced fraction or put it in a decimal, that's okay, but just for the sake of ease here, I'm going to remain in the base fractions that we calculated. Okay, so alpha in this particular case would be equal to 2/20. So notice for our particular rejection rule that we're working with, alpha turned out to be equal to 2/20. Now that's not going to change for the rest of what I talk about. Alpha is going to stay fixed. But now what I'm going to do is I'm going to go take a look at some observed values, okay? So let's pretend, let's just say that you grab this bag, you know, it's bag A, and you reach into it and you pull out a $40 voucher, okay? So pulling out a $40 voucher would be your observed value, okay? So you observed a $40 voucher. So if the voucher was equal to $40, if that's the case, if you have a $40 voucher, then what's going to be the corresponding p-value that goes with that? Well, to calculate the corresponding p-value, notice that we have to do is take the observed value and more extreme and look at the chances of seeing that value more extreme. Well, notice that's going to be what? 1, 2, 3, 4 of those vouchers. So the p-value in this case is going to be equal to 4/20. All right? Now, let's do it one more time. But this time, let's assume that the observed voucher that we pulled out was not the $40 voucher, but what we pulled out of the bag was the $60 voucher, okay? So if the value of the voucher in this case, so change again to a different color here, let's say the value we pulled out was equal to $60, in that case, well, what's the p-value going to be? See if you can get a little ahead of me here and see what you think the p-value is going to be. Well, notice there's only one voucher that's 60 or greater. It's the one over the top of 60, so that's going to be equal to what? 1 out of 20, right? Okay, now here's the big fat hairy deal. The thing to notice is that in the case of the green situation here, notice that we fell outside of the rejection region. And since we fell outside of the rejection region, our decision here with a p-value of 4/20 would be to accept the null. On the other hand, if the voucher we picked, the $60 voucher, fell in the rejection region, well, then our result, our decision would be to do what? Would be to reject HO, right? And in that lies the usefulness of the p-value, okay? Because notice when we accepted the null, the p-value was larger than alpha, and when we rejected the null, the p-value was smaller than alpha. Okay, well let's say that a little more concise here, okay? So let's go ahead and do that. Interpreting the p-value. We interpret the p-value in the following way. What we say is that small values of the p-value, in other words, if you have a smallish value, or there's a small probability, would indicate that you have evidence against the null hypothesis. They indicate that the value drawn is in the rejection region. Let's go back to what we just did here. Look, take a look at the orange. In the orange case, with the orange highlighter here, in the orange case, notice that the p-value was really small, it was 1/20th, and notice that that also indicated for us that the value that we observed was in the rejection region, okay? If that p-value is not small, if it's larger, in particular large when compared to alpha, okay, then notice that in that case, right, that when we had a larger value of p-value, in this case 4/20, then our observed value fell outside of the rejection region, okay? All right, so that leads us to the following. This is the big deal on page 32 of your book. This needs to show up in your comp book. This is obviously a really big deal here, okay? So take some time, put in your comp book, get a sticky note, write this down, stick it on the mirror in your bathroom so you look at it at least once a day, okay? All right, so here's the key ideas. All right, I got them pre-highlighted for you here. The relationship between p-value and alpha is the big deal, okay? If the p-value is less than or equal to alpha, then we reject the null hypothesis and the data are stated to be statistically significant. If the p-value is greater than alpha, then we accept the null hypothesis and the data are not statistically significant. You need to memorize this. Muy importante, okay? All right, so let's go finally get into LDI 1.9, chromium substitutes. This shows up on page 29 of the textbook. And this is actually, if you understand everything we just talked about, it's actually a very simple, straightforward LDI, okay? So according to the study in the American College of Sports Medicine Journal in Science and Sports and Exercise, men who trained while taking chromium supplements did not grow appreciably stronger than did men who trained without it. 16 men were monitored in the study. Half got the chromium supplements and the other half got a fake substitute. So half got the supplement, half got a placebo. At the end of the training program, both groups had become stronger, but there was no statistically meaningful difference in the strength gains, the study reported. Consider the following hypotheses. The null hypothesis is there's no difference in strength gain, okay? So no difference in strength, all right? What that means is status quo, nothing changed between the two groups. Alternate is the chromium group had a higher strength, okay? So now based upon the results that were here, okay, which hypothesis was supported by the data and explain? Okay, so let's go back up here and just take a look at what they said up here. They said what? There was no statistically meaningful difference. So no statistically meaningful difference, which means it was not statistically significant. So if it's not statistically significant, then which hypothesis would we be supporting? Well, we would be supporting the alternate hypothesis, not the alternate, the null. I circled the right ones in the wrong. We would be supporting the null hypothesis if the data was not statistically meaningful or not statistically significant. Would the p-value for the testing above hypothesis have been somewhat small? Okay. Well, what can we say here? All right. Well, let me get the font down to a reasonable size here for you. Well, we hopefully, from what we just discussed, you see that the p-value would be small. Why? Well, excuse me, large. Excuse me, I said small. I say large. Why would it be large? Well, the p-value would be large because why? Well, the data was not statistically significant, which means the p-value had to be larger than alpha. So we can say the p-value was larger than alpha. Okay? So if the p-value was larger than alpha, in that sense, we know it's slightly larger. Okay, why do we know that the p-value was larger than alpha? We know this because why? We accepted the null hypothesis, right? Okay. Hopefully that all makes a lot of sense. Now look, this is a key idea for the entire course. You really need to make sure you understand the relationship between the p-value and alpha. And you need to understand this probably almost as much, if not more, is the interpretation of the p-value. Is that small values of the p-value indicate that we have evidence against the null hypotheses. Now, if you think about it in terms of our earlier discussion, that makes a lot of sense, because the p-value is going to be the probability of making a type 1 error based upon the observed value. So if that value is really small, then the chances of rejecting the null when in fact it was true are also going to be really small. Okay? So hopefully that helps. If you have any further questions, of course, as always, be sure and send us requests. We can do these, any of these that you need for further clarification. Okay?